Let's try another systems of equations problem. What we have here is two different lines, and we're trying to find which of these systems has a solution. 8, 11, this being the point of intersection. And the slow way to do this would be to graph all of these lines. We have a line here, a line here. We have another two lines here to graph, and another. This would take too long. So the faster way to verify which of these systems have this solution would be to plug in the point. So let's try plugging in. This is your x value, 8. This is your y value. Let's test. Let's plug point into the equations. And the key here is if the left side is equal to the right side for both equations, not just one, both, then it means that our point is the solution to the system of equation. The system of equations. Okay, so let's test it out here. We have 8, 11. Look at test system A. We have 6 minus 2y equals 2x. So what I'm going to do is the y and the x's I'm going to replace with 11. That came from here. And the x happened to be 8. So does the left side, this is a question mark, does it equal? And what we have is 6 minus 22 is negative 16. Does it equal 16? And the answer is no. So immediately we eliminate choice A. Let's test system B. Let's plug in some values here with x plus y equals 8. So does 8 plus y, which happens to be 11, does it equal 8? And you can see clearly that left side is 19, and the answer is no. So B is not the system for this solution. Let's try C. Test system C. We have 2y minus 6 equals 2x. So 2 times y minus 6, does it equal 2x? 2 times 8. And what we get here is simplifying 16. Does it equal 16? And the answer is yes. But just because this one here is true does not mean that this is the system. We have to try out the second line as well. So let's look at the second line. 5 plus y, y happens to be 11. Does it equal 2 times x, which is 8? And indeed, 16 does equal 16, yes. Because we have two yeses, we know that we've found the solution to the system. This here is the point of intersection, and the key take-home message to remember for this example is that when you plug in a point's x value and y value into a system, into both equations, plugging in the x and the y values, if left side equals right side for both, not just one, but both, it means that this point is the point of intersection. If left side does not equal right side for either one of these equations, it means that the point is not the solution. It's not the point of intersection.